So, when talking about circuits, it's important that we come up with two more vocabulary words besides resistance, impedance, or resistance, voltage, current, even resistivity, inductance, capacitance, all those things. There's a couple more words we need to know. Well, a couple more phrases, I guess. The first one's known as EMF. It stands for electromotive force. The interesting thing is that it's not a description of a force. A force is applied usually to create an EMF, but the EMF itself has nothing to do with forces. And what we need to know about EMF is that it's the maximum potential difference. It's the maximum voltage. Now, when you're measuring the voltage across two terminals, you're not actually measuring the EMF. You're measuring the voltage that's being able to be delivered to the circuit. It turns out that inside that circuit, there is resistance. And it's not like a resistor resistance. It's the material. It's the plates in which everything is separated by. There's a whole series of things that causes this resistance value. As a matter of fact, we don't even really call it resistance. We call it something else. We call it internal resistance, which is inside the battery. And once again, it's not about the copper terminals. It's a whole bunch of other things that contribute to that internal resistance. Okay? So we have an internal resistance. So in an example of a battery, a 120 volt battery, that we have an EMF in there that's over 120, and I'm just going to pick a number, how about 150? Inside that, well, let me write that 150 a little bit better. But also, inside that battery is the internal resistor. And the voltage that that thing consumes is the current of the circuit, which is everywhere, regardless of whether it's inside the battery or outside the battery. It's relatively constant. Times the internal resistance. So what we can say is that this voltage across the terminals is equal to the EMF minus the current in the circuit times the internal resistance. Okay? So the voltage across my terminals is equal to my EMF minus the current times the internal resistance. Okay? So when we talk about EMF, that's what we're talking about. We're talking about the maximum possible energy. But we don't ever get our maximum possible potential difference. But we don't ever get to use that because of an internal resistance.